Here you go. Tēnā koutou katoa, and welcome to another Link Online webinar. I am Mona Mokhtari, Principal Government Advisor at Commercial Team in the Land Care Research, and welcome you all into this session today. Today's speaker is Dr. Warwick Allen. Warwick is a researcher who is interested in how species interactions influence community structure and ecosystem functioning, especially their role in mediating the causes, consequences, and management of invasive species. So he presents about ecological impacts of Cyclone Gabrielle today. Before handing over to him, I would like to give you a bit of underway about housekeepings. This webinar is recorded and will be made available online in the coming days. And the Q&A function is also enabled live, so you can ask your questions here as we go, and then we'll aim to answer these at the end of the presentation. Here you go. I will hand it over to Warwick.
Great. Thank you, Mona. Ngā mihi kia koutou, ko Warwick Allen toko ingoa. Today I'm going to talk to you about a large research project we've been working on over the last couple of years, looking at ecological impacts of Cyclone Gabrielle. And just before I get started, I want to first acknowledge everybody who was impacted by Cyclone Gabrielle. It was a hugely traumatic event, and there are going to be some photographs in this talk today that could be triggering to people. So just a bit of a warning before I get started. So Cyclone Gabrielle was an ex-tropical cyclone that crossed along the northeast of the North Island of New Zealand in mid-February 2023. As you can see from these aerial photographs, it was a large storm. And we often associate cyclones, or hurricanes as they're called in the Northern Hemisphere, with strong winds. Sort of conjures images of palm trees in Florida flattened. But here, Cyclone Gabrielle wasn't such a wind-driven event. There was still sort of strong winds, especially in the central North Island, which is what this figure's showing. But it was actually more of an event that was driven by extreme precipitation. And so this figure shows where that precipitation occurred over the course of the storm. And you can see largely concentrated in the east coast of the North Island, Hawke's Bay and Te Tairawhiti. And when combined with the preceding cyclone hail and the Auckland anniversary storm, Treasury estimated that combined this cost the country around $9 to $14.5 billion in immediate damage to critical infrastructure. So yeah, quite a severe series of extreme weather events. And these aren't as uncommon as you think they would be. Just in my lifetime, there's been several named cyclones that have struck New Zealand and caused impacts. And they are expected to become of higher intensity in the future. And there's also evidence that they are shifting polewards. And so we could potentially see at least a similar frequency, if not more frequent cyclones in New Zealand. And so when an event like this occurs, like Gabrielle, it's an unfortunate opportunity to prepare for the next one. And so we could use Cyclone Gabrielle as an opportunity to identify the ecosystems and species that are most at risk. Now, to put this all into a bit of, historical context, in the past, when cyclones would have hit New Zealand, our ecosystems looked quite different. So this is what they might have looked like pre-human Aotearoa, with bush-clad hills reaching down into the river plains. And you can see lowland floodplain forests, braided rivers, and a fairly intact ecosystem. And then humans arrived, and we've transformed the landscape, and we've transformed it by deforestation, planting with pasture, planting with exotic plantations. And this has created a much more vulnerable landscape. And so you end up with events like Cyclone Bowler in March 1988, with large erosion scars across that hill country. And we clearly didn't learn too much in the following 35 years, because then Cyclone Gabrielle hit, and we see much the same images. Highly erodible landscape, and all of that soil and sediment that's eroding is washing down into the awa, into the rivers, and then traveling all the way out into the marine ecosystems as well. And so that's what I'm going to talk to you about today is I think the story of Cyclone Gabrielle from an ecological perspective is one of erosion and sedimentation. And so after the cyclone, Manaaki Whenua and Niwa were contracted by MB under the Extreme Weather Research Platform to assess the immediate ecological impacts. And we had three main objectives. The first one was to identify changes in the extent and condition of vegetation cover. The second was to evaluate impacts on wetlands and other naturally uncommon ecosystems. And then Niwa led the charge on assessing resilience of freshwater fish and macroinvertebrate communities. This slide is providing a bit of an overview of the project as a whole. I'll leave it up to you to interpret the different points on the map, but what I would like you to sort of cast your eyes over is that you can see where we concentrated the work was also where you saw those biggest impacts of rain and erosion. So Hawke's Bay, Te Tairāwhiti, and around Auckland and Northland as well received the bulk of our efforts. And this is also a good opportunity to just acknowledge all of the amazing research partners who made this work possible by providing data, providing access, helping support the project in just countless ways. So a big thank you to all of the research partners who made this possible. Okay, so on to the first objective, that was to identify changes in the extent and condition of vegetation cover. And we were lucky that our colleagues at Manaaki Whenua were also contracted by MFE to do some work in this area, and they mapped where damage to land occurred. And so this was led by Andrew McMillan and others. And basically they took quite a simple approach, but it was really effective, of comparing aerial imagery or satellite imagery from before versus after the cyclone, and looking for areas where the pixel sort of color had changed from green to brown, indicating that erosion had occurred or sediment had been deposited. And they were able to map this, and this is what the resulting map looks like for the East Coast area. And you can see darker red areas represent those where there was more bare ground, essentially. So that's what the map looks like. And then they took that a step further. Essentially that also equates to about 300 million tons of sediment eroding away. So this is a huge amount. And because of that land use change, it's a lot more than it was historically if that was bush-clad hillsides, for example. And we know this for several lines of evidence, but here's one from the McMillan et al. Report. This shows intersecting that land damage map with the land cover database to sort of see, well, which ecosystems, which land use types suffered the greatest probability of erosion. And this is just for a couple of districts, Gisborne and Hastings. But the key takeaways here is that it was these modified landscapes, exotic grassland, exotic plantation forest, and also recently harvested forest that had the highest probability of erosion occurring. And if we contrast those values to those of our indigenous forest, or even through to early successional forests like Mānuka or Kānuka, we see a lot lower probability of erosion in these native forested landscapes. And then my colleague James McCarthy took this damage layer and did some additional analyses to it as well. And one of the highlights, or one of the more interesting findings there, not unexpected, but it's cool to see the numbers, was that you saw more new bare ground closer to rivers than away from rivers. So this again sort of suggests that the sediment was eroding from the hillsides, flushing down into the rivers, and then spreading out across the landscape from the rivers. So yeah, this was not good news. And we saw overall that despite there being low probability of erosion occurring in indigenous forest, this didn't mean that there were no impacts. And so one of those impacts that we started to hear about and see when we were on the ground was that the sediment was flowing into lowland floodplain forest and having some impacts. And those impacts were gradually becoming more apparent as the trees got more stressed. So this photo is from Te Tairāwhiti, about 45 minutes northwest of Gisborne. And you can see this lovely kahikatea forest, it's a Kiwi2 covenant, looking quite stressed. And this is 6 months after the cyclone. And it had 70 plus centimetres of sediment flooded through that forest and deposited there. And you can see the trees are looking kind of sickly. And then we fast forward to a couple of months ago, April 2025, and it's looking far worse. Those trees are dead. And so this sort of made us think, well, we need to do something about it. I've got some other photos, again, from inside that forest, the same forest here. This is before the cyclone, February 2021. And you can see there's a healthy looking understory. It's a normal looking sort of kahikatea forest. And I'm going to show a series of photos, all taken from the same point, and you can orient yourself with the punga in the middle. Here's after the cyclone, so about 6 months after, the understory completely gone. Not much coming back, it's just a bit of a litter layer. But we need to remember that that canopy is slowly dying back as well due to the stress of that sediment deposition. And then this is April 2025, so again, a couple of months ago. It's greening up, but it's not greening up in a way that says the forest is regenerating. It's greening up in a way that says, well, we're going to replace this dead forest with pasture and exotic weeds. So, yeah, we combine forces with a bunch of organisations and mana whenua and the Gisborne District Council in Te Tairāwhiti, and we had this goal that we wanted to quantify these impacts and then assess recovery of these lowland forest fragments. And this is because they're a regionally rare ecosystem. They're also home to several threatened plant species, and they're facing multiple pressures, not just extreme weather, but also impacts of ungulates, impacts of exotic weeds, and all the surrounding land use that's driving that pressure. So yeah, we partnered with mana whenua, we partnered with a lot of other organisations, and we went to 19 forest fragments and installed 41 permanent monitoring plots there. We collected a lot of data, but one of the key things we did was try to assess the cyclone impacts. We did that by measuring flood heights. So this is a photo showing polar measuring the flood height. We did that by looking for hanging debris in trees and bushes. In some instances, we found flood heights of over 3.5 meters. And then we also assessed tree health by giving each individual tree that had a diameter at breast height of more than 2.5 centimeters a dieback score. So we assessed whether the tree was healthy, and that got it a score of 0, all the way through to dead. And we tried to distinguish recently dead from the cyclone versus those that had clearly been dead for a long time. You know, they were decaying. And then we also had scores in between of minor and major stress, depending on sort of how discoloured the vegetation was looking, how much proportion of leaves was remaining, and those sorts of things. But the key thing here was that we found that there was no relationship between these tree dieback scores and flood height. And this could be due to several reasons, potentially because we didn't know how long that water had stagnated there and sat around. So that might actually be a more important factor than the height itself. But what we did find was that tree dieback had a strong positive relationship with sediment depth. So as you got more sediment choking the trees and stopping gas exchange from occurring, those tree dieback scores increase. And we've just measured sediment in the most simple way possible, digging holes, and then you can quite clearly see from this photo that there's this mineral soil at the bottom, followed by the sort of sediment coloured, or the grey sediment, and then a little layer of leaf litter on top. So yeah, strong impact of sediment on tree health. These effects did vary among species. So for some species like titoki, there wasn't a clear relationship between sediment depth and dieback. But for other species like kahikatea and mātai, we did see a strong positive relationship, albeit the kahikatea one potentially driven by a single site there. This data we think could be useful for planning where you might do native afforestation in the future. If we know something about the tolerance of various species for sediment impacts or flooding, then we might be able to better predict where we should plant certain plant species, right? One caveat is that these long-term impacts remain unknown. You'll remember the photo I showed of the forest looking sickly in 2023 and then really like bleached coral in 2025. So some of these trees, the dieback may get worse, and for others like Pukatea, we heard anecdotally that the dieback was they were starting to recover. And so I think it would be important to continue to collect these data, and so that's why we've set up these monitoring plots that we can revisit in a few years from now. Another question we asked was, is forest regeneration occurring? So yes, we found 5 times more native saplings in fence forests. So yes, it was occurring, but this was dependent upon the management that was taking place. We also found that weeds were a problem in some sites. This was a bit more of a complicated story, but weeds were especially a problem when you had that canopy dieback opening up the canopy and allowing light in, and then you're replacing that forest with pasture. And so the goals are that if we can, I guess, use proper management in these forests, fencing, managing weeds, we can hopefully create more resilient forests that are able to recover when they're stressed by these extreme weather events. Okay, so on to the second objective, which was to evaluate impacts on wetlands and naturally uncommon ecosystems. I've got a couple of brief examples to share with you from here. First of all, wetlands. We partnered with Hawke's Bay Regional Council and Auckland Regional Council to make use of their state of the environment monitoring programs, where they regularly visit wetlands, where they've got permanent plots set up as well. And so we were grateful to be able to use those pre-existing data and then revisit some of those sites. What we found overall was that wetlands were providing a really important service. They were holding a huge volume of water during the cyclone, and all that water that goes into the wetlands is not washing across the land and causing erosion and shifting sediment. It's being held there. So they're really important. And you can see this from the water pressure data from a water logger in the Hawke's Bay on the right here. There's 2 big peaks, the first for Cyclone Hale, the second for Cyclone Gabrielle. And I think those represent potentially maxing out of the water logger because they're both the same size. So the actual peaks might have been a lot higher. And that water was retained in some cases for long periods of time. This wetland that my colleague Paul is standing in used to be dry when the plots were installed. And this is 6 months after the cyclone, and it's still up to your waist. The other good news was that not only did the wetlands provide a service, they were also largely resilient. So we assessed wetland condition index before and after the cyclone, and this is sort of a composite measure made up of about 25 different qualitative metrics that you assess when you visit the wetland, including things like predator impacts, sedimentation, nutrient levels, connectivity, all those sorts of things that determine whether or not a wetland is in good condition. And in Auckland, we found no change in wetland condition before and after the cyclone. And in Hawke's Bay, we did see a small decline in wetland condition of around 4%. And this was largely driven by sedimentation and damage to vegetation. And this, I could show the data, but I think this photo sums it up nicely. You can see the wetland circled in red. And in the foreground and also in the background, you can see large numbers of slips that are driving sedimentation of that wetland and also helping flatten vegetation and stuff like that. Another ecosystem that we visited was Hawke's Bay's braided rivers. You can see from this photo that there's a clear impact again of sediment washing down these rivers and spreading across the adjacent land as well. This was again in partnership with Hawke's Bay Regional Council and Nikki MacArthur, an independent ecologist. And they have an amazing data set. So for the 3 years leading up to the cyclone, Nikki and his team walked all 292 kilometres of these rivers and counted every single bird that they encountered. There was a focus on native shorebirds. And then every 200 metres, they quantified vegetation and substrate cover, breaking down the substrate cover into different size classes from silt, sand, gravel, pebbles, cobbles, and so on. And then we repeated this survey immediately after the cyclone to see how bird numbers, vegetation, and substrate cover had changed. And I'll present a couple of quick results from that here. One of the key findings was that fine substrate increased. So this figure on the right shows the percent cover of each different substrate size class before the cyclone, and it's broken down into the 3 main rivers, Naruroro, Tukituki, and Tutaikuri. And the warm colours represent finer substrate size classes, the cooler colours, coarser substrate. And what you can see is clearly after the cyclone, there was a huge increase in those fine substrate size classes, silt and sand especially, and that this was largely in 2 rivers, the Naruroro and the Tutaikuri. And we see similar findings when we look at the birds. So this is Pohowera, banded dotterel, Overall, it declined by 15% across those 3 rivers. And the figure shows the density per hectare of banded dotterel pre-cyclone with the light grey, and then post-cyclone with the dark grey. And you can see there's a decline in the Naruroro and the Tutaikuri, but not in the Tukituki. And that the strengths of those declines, or lack of decline, correspond quite nicely with the changes in the substrate composition. And we saw similar results across all of the key native shorebird species that we were interested in. Declines for black-fronted dotterel, poaka or pied stilt, or torea, and torea, South Island pied oystercatcher as well. The final objective was to work with NIWA to assess resilience of freshwater fish and invertebrate communities. Now, I'm not a freshwater ecologist, so I'm not going to cover that today, but I think you can see from this aerial image there's clear impacts, and again, it's clearly driven by this flushing of sediment down through the rivers and out to the ocean. And so if you want more information on freshwater ecosystems and their impacts, Cindy Baker led an amazing team working on that. And then there was also projects that were looking at the marine ecosystems through NIWA as well. So there's lots of information out there on those ecosystems if you'd like to find out more. So just to wrap things up with a few key conclusions, Cyclone Gabrielle was characterized by extreme rainfall, erosion, and sediment deposition. Its impacts were likely exacerbated by this historical land use change and then also current management practices. Additional pressures like invasive weeds and ungulates could alter, delay, or prevent the recovery of these ecosystems. And I think it's also important that we highlight that it was actually long-term monitoring programs that were crucial for us to be able to quantify any of these impacts at all. And just finally, a few recommendations. We've got some great infographics that have these recommendations with the report. But I think overall, the idea would be that we should be aiming for whole catchment resilience. This involves protecting and restoring wetlands because they provide that important flood and erosion mitigation, not just at higher elevations, but at lower elevations as well. We should protect and restore native vegetation. It's clear that this would help to stabilize landslides and reduce future erosion. We should learn our lessons from Cyclone Bola and Gabrielle. These natural habitats should be fenced to exclude stock and feral ungulates. This will promote regeneration and increase their resilience. And we should monitor for weeds and act swiftly to prevent their establishment and further spread. So, as I mentioned before, there was a huge team involved in all of this. I won't name names, but just a big thanks to everyone who made this work possible. And if you want more information, there's a report summary and infographics that will be available. You can download the full report by using this QR code, and you can also feel free to pop questions in the chat or reach out to me. Thank you very much.
Thank you so much, Warwick. I'm seeing lots of hands, lots of praise coming everywhere, including the chat. Thank you for fantastic and interesting presentation. So I would start with the question. If people can put their question in Q&A, that would be much easier for us to follow all of them. I start with the first one in the Q&A. Given that exotic grasslands, key farming areas appear to be disproportionately affected, was any analysis done to explore whether different farming practices such as integrating trees, forest lots, or riparian planting offer greater resilience to weather-related impacts?
That's a good question. I'm not aware of any analysis that sort of went down to that scale or level of looking at I guess, different compositions of land use types. I think it would be useful. And we should be thinking about, what area, being able to predict what areas are most at risk. And I think there's been some good work done on that that's helped inform where management might be directed in Te Tairāwhiti, for example.
Nice. Thank you. I go with the other question in the chat bar. How did Macmillan account for activity created bare ground versus storm damage? This will be particularly important with plantation forestry harvesting.
I think that question would be best directed for the remote sensing team that created that layer. But I think I have an understanding that for their initial analysis, they didn't use the flat ground because there was some potential confounding of people, I guess, clearing fields and stuff like that. So there should be more information in the report, or I'd encourage you to reach out to Andrew and his team.
Oh, I would like to read the next one. Please get these messages into mainstream media loud and strong. The NZ public need to know this.
Great.
The next one, excellent presentations. Very thank you. And fantastic presentation. This is so fascinating and useful for explaining how nature-based solutions can assist with climate change mitigation. Cool. The next one says, was there any analysis possible looking at the mortality of early succesional species, example Manuka?
Looking at mortality, yes. So our lowland forest plots did not include different forest types. So because we sort of wanted to have I guess a decent sample size and not spread ourselves too thinly across multiple land use types, we focus largely on lowland kahikatea forest. But I think it would be great to have a good understanding of mortality around Kānuka and Mānuka, and whether they were affected in the same way that we saw these trees by sediment deposition and flooding. We don't have that data. Anecdotally, I've heard that they're quite resilient. But I think there's many opportunities for this sort of work to be extended or more data to be collected, because I think that sort of information would be really useful for informing future planting to increase resilience. So I think that's a great question, and I think there's just more research needs to be done. Yeah.
Right. Thank you, Warwick. The next one I've got is great presentation, such a good example of well-done, thoughtful science with huge relevance for public policy. Maybe we will pay more attention than we did after Ebola.
Well, thanks for the nice comments, and we can hope. We're trying to get this information out as widely as possible. I was very grateful to spend a week up in Te Tairāwhiti a couple of weeks ago having community meetings and meetings with various organisations that can hopefully help spread the word. And 100% agree that this sort of information needs to get out there.
Great. The next question we got here is, were there any examples of better managed catchments than were less impacted in the areas analysed?
Oh, that's a good question. No, I don't know. I don't think I can answer that. It's really hard to say, because I don't know if management varies enough in the areas that were affected to really get at that.
Yes.
Yeah. Good question though.
Yeah. Cool. Is there a similar study for other regions affected, for example, Auckland?
Not for like lowland forests, but we did assess wetlands in Auckland, and that's included in the report. We did go into other regions, so we also assessed impacts on sand dunes in Northland, working with Northland Regional Council. Multiple different ecosystems, multiple different regions.
Nice. We've got the next one. Tell us more about what underpinned your success with partnering with Mana Whenua.
I think many things. I guess engaging early was good. It's quite a lead-in time to have those interactions and to develop, I guess, a project together. And just sort of, I think, keeping communication open was another really key thing, and reporting back on what we found. All of those things were really appreciated, and involving the community when we went to do the work. not just for Mana Whenua, but for all of the sites that we visited. We had kura come out, multiple different people from multiple different organizations joined us, and that made the experience more rewarding for everybody. And I think we all took things away from it, from those experiences. So yeah, it was great.
Thank you so much, Warwick. I'm just conscious of time, so it's 11:30. Thank you very much for your presentation. And I would just like to thank you, everyone, for joining us, and just letting you know any unanswered questions will be answered and shared with the email recording of the presentation, plus the reports Warwick already talked about. Recordings also load to YouTube, so keep an eye on that, and also keep an eye on our website for upcoming link online webinars. So see you everyone later in the next session, and you have a great day. Thank you.